All right, here's some homework help for the quadratic equations section. First question, they have two factors is equal to 0. That's just perfect for the 0 property. So to solve, I can just separate those. 10r plus 7 is 0, or 3r minus 9 is 0. Moving the 7 to the other side, dividing by 10. So I get r is equal to negative 7/10. Moving the 9 to the other side, make it positive. Divide both sides by 3. So there we go. So the solutions are, so use a comma to separate them. So negative 7/10 as a fraction and positive 3. Those are my answers. Next question, I need to solve that. There's no x term, so what I'm going to do is I'll just divide both sides by 4. So x squared is equal to 7, and then I'll use the principle of square roots. So square root this side, square root this side. This cancels, and on this side I have to remember my plus or minus. So I have x is equal to a positive or a negative root 7. So the answer is, I think in my labs you can put a plus or minus in front and then have a root 7. Hey, these are going fine. Ooh, there's a cube. Looks like there's a common factor, though, of each of these. I can take out a y. Let me do that. Take out a y, left with 7y squared minus 20y minus 3 is equal to 0. And then I'm going to try and factor that thing. 7y and a y. Probably a 3 on this one, a minus 3 and a plus 1 here. 7y squared minus 21 plus 1. Yeah, that's minus 20. That's right. Equals 0. 0 property comes in, so either y is 0, or 7y plus 1 is 0, or y minus 3 is 0. The first one's done, so 0 is one of my answers. The other one, I'll subtract 7 on each side, and then I'll divide by 7 on each side. And on this one, I'll add 3 to both sides. So my three answers are those. Use a comma to separate. Okay, so 0, negative 1/7, and positive 3. Question 4, use the graph to find the x-intercepts. Oh, they're right there and there. That was easy. So let's see, that's a negative 1. So one of them, and I have to be an ordered pair. So the first one is negative 1, 0, comma, and the next one, 1, 2, 3, 4, 5, I think, 5 and 0. Then they say the x-intercepts are, or the zeros are, here you just have to put the numbers in. So negative 1, comma, 5. Notice you don't put brackets around this because it's not a point. It's just listing two x-intercepts. Solve by completing the square. Ooh, this is a nice one for completing the square. I'll move the 41 to the other side. So it'll be x squared minus 10x is equal to a negative 41. Then I'll take that 10, divide it by 2, and square it. 5 squares 25. So I'm going to add 25 on this side. If I do it there, I'll also add it on this side. So for this one, I'll get x minus 5 squared is equal to, that's negative 16. Now I'll use the square root principle to cancel that square. If I do it there, I have to do it here too with my plus or minus. So I have x minus 5 is equal to the plus or minus square root of negative 16. Okay, dealing with a negative under the square root, I can change that to plus or minus root 16i. And then the square root of 16 is 4. So that'll be plus or minus 4i. Now to solve for x, I need to move the 5 over to the other side, so I'll add 5 to both sides. So it'll be a positive 5 plus or minus 4i. Type an exact answer using radicals as needed or complex numbers. So 5 plus or minus 4i. That's my answer. Next question, solve. Ooh. So 4z squared minus 24z plus 29 equals 0. I need to make it equal to 0, so I just subtracted 24z on both sides. And I put it in the right order. Now to factor. Oh, great. 4 times 29. That's a big number. 118 or something, 116. Things that multiply. Nope, not going to try it. I'm going to do quadratic formula. So minus b plus or minus square root of b squared minus 4ac all over 2a. I'm going to pause while I do the rest of it. Okay, I did a bit of it. Now let's keep going. So this would be x is equal to 24 plus or minus square root of, is that 112? All over 8. 112 looks a little suspect. 112 divided by, is that 16? Will 16 go into that? 16, say, times 8. 48, 4, no, that's 128. Oh, 7, though. 42, 4, yeah, it's at 7, 16. So that's 16. Let me just rewrite that. 16 times root 7 all over 8. X is 24 plus or minus 4 root 7 over 8. Now, last thing to do is I can divide 4 into this, this, and this. So 4 goes into 24 6 times, plus or minus. 4 goes into 4 once, so that'll just be root 7. And then 4 goes into 8 twice. There'd be my answer for that question. Yeah, so 6 plus or minus root 7 all over 2. Oh, another quadratic formula question. Okay, so x equals minus b plus or minus 4ac all over 2a minus b. I'm going to pause, let you do that on. Okay, I'm almost done here. So this would be minus 8 plus or minus 68 is 4 times 17. So again, I can do some simplifying. Plus or minus 2 root 17 all over 2. So 2 will divide evenly into 8 and 2 and 2. So 2 goes into minus 8 and minus 4 times, plus or minus. 2 goes into 2 once. So 1 root 17 over 2 divided 2 is 1. I guess I don't need to put the 1 down below. So that would be my answer for that one. All right, in this question, they asked for something called the discriminant. And the discriminant is something that just tells you whether, basically 3 things, whether your graph crosses the graph twice, the x-axis twice, or just comes and touches once, or if it doesn't cross the x-axis at all. In this case here, the discriminant would be greater than 0. In this case, the discriminant would be equal to 0. And in this case, the discriminant would be less than 0. So, if you're given an equation, you have to first make sure it's equal to 0. So this I'm going to change to 2x squared minus 8x minus 4 is equal to 0. And then I'm going to do that b squared minus 4ac thing. So something squared minus 4 times a couple somethings. Okay, b is a negative 8, a is 2, and c is a negative 4. So negative 8 squared is a positive 64. 4 times 8, negative 8 times negative 4 would be positive 32. And this comes out to 96, but positive. So if it's positive, it means it's that graph, greater than 0, so it crosses twice. So what are the nature of the solutions? 1, no. 2 different imaginary, no. 2 different real numbers, that's the one right there. 2 different, so there'd be 1 there and 1 there. Okay, this one asks to find the zeros of that function. So to find the zeros, I'm going to let f of x be 0. and then I'll try and solve this equation. Can't factor it, can't, I guess I could use a quadratic formula. You know, I'm going to just complete the square with this one. I'm going to add 4 to both sides. So I'll get 4 is equal to x squared minus 6x. Maybe I'll just switch everything sides. I'm a left-handed kind of switcher guy or solver guy. Okay, so now I'm going to take negative 6 divided by 2 and square it. So I'll have x squared minus 6x. And when you do this, that gives you 3 squared to 9. So add 9 on this side, add 9 on this side. So here I'll have x minus 3 squared is equal to 13. Square root principle, x minus 3 equals plus or minus root 13. Add 3 to both sides. So I'll get 3 plus or minus root 13. And that'll be my answer. So the zeros are, now what did they say? Use a comma to separate answers as needed. Yeah, so just, I think in my labs you can just go 3 plus or minus root 13. I think that should be good. Okay, next question. Find the zeros of this function. Okay, this one, it doesn't look as though I can factor it, and completing the square would be a pain. So I'm just going to change the f of x to 0, and then I'm going to use the quadratic formula. I'll pause, I'll do it, and then I'll press play. Okay, I used the quadratic formula, and I came up with 7 plus or minus the square root of 205 over 6. I don't think you can simplify that anymore. And so that would be my answer. Okay, next question. Solve this one. Oh, okay. So, it's an x to the 4th. Interesting. And it's not equal to 0. Let's fix that. X to the 4th plus 6x squared minus 55 is equal to 0. Okay, just looking at some of the answers down there with 11s and 5s, I'm thinking that if I factor that, that's what I'm going to get. So x to the 4th, I'm going to change to x squared and x squared. Things that multiply to 55 add to 6, 11 and 5 probably. So positive 11 and a minus 5 is equal to 0. Now I should have done this over on the side somewhere. Let me continue up here. So then either x squared minus 5 is equal to 0, or x squared plus 11 is equal to 0. Both of these I can use the square root principle. So I'm going to add 5 to both sides to isolate that x squared. Then I'll square root this side, square root this side. This, I'll need to put the plus or minus. So x is equal to a plus or minus root 5. I'll do the same thing over here. So x squared is equal to a minus 11. Square root principle. So it'll be x is equal to a plus or minus square root negative 11. So, and the square root of a negative, I can change that to square root 11 and put an I there. So I'm looking for this and this. I'm thinking that one right there. Okay, number 12. After declining between 40 and 80, the number that function can be used to estimate the number of multi-generation households in country A in millions, X years after 1940. In what year were there 40 million generational households? So that 40 million goes in right there. So it'll be, so the function is h of x is equal to 0.012x squared minus 0.573 x plus 35.725. So I'm plugging a 40 in right here. 12x squared 573x plus 35.725. It's a quadratic, so I need to make it equal to 0. So I'll subtract 40 on both sides. So I'll get 0 is equal to this stuff. 0.573x. That'll be a minus 4.275, I think. Yep. Okay, so now I'm not going to try and factor that. So with this one, I would just take it and use the quadratic formula. So this is A, this is B, this is C, and plug it in. I'm not going to finish that, but that's how I would do that question. Last question. Open box made of 40 by 50 centimeter piece of tin, and you cut a square out of each of the corners and then fold them in to make a box. Okay, the area of the resulting base is 816. So this piece in there is 816, just the bottom piece. What is the length of the sides of the squares? Okay, well, I don't really want to know this whole distance. All I want to know is this distance, because that's what one of these lengths will be in here. So, and I also don't know how much I'm cutting, because they say what's the length of the side of the squares, but really I need to figure out how much I'm cutting off. So that piece in there we'll call X. So there's an X there and there'll be an X there. So really this distance from here to there is going to be 50 minus those two X's. Similarly, if I want to know what the width of this thing is, I'll use blue. So to go from here down to there, again, there's an X here and an X there. So that distance from here to there is going to be 40 minus 2x. So that's what this distance is, 40 minus 2x. And this distance is 50 minus 2x. And so they say that the area of the base is 816. You get that by multiplying the length by the width. So area is equal to length times width. Area, they say, is 816. Well, the length is 50 minus 2x, and the width is 40 minus 2x. Now, hopefully I'll get a quadratic equation out of this. 50 times 40 would be 2,000, minus 100x, minus 80x, plus 4x squared is equal to 816. Okay, let's rearrange things. So my x squared is first. This would be negative 180x if I combine these guys. And then if I bring the 816 over and subtract, well, let's leave it for now, and then subtract 816 is equal to 0. So I've got a quadratic, I have to make it equal to 0. Then we try some factoring games with it. Okay, 2,000 minus 816 would be 1184. So negative 180x and 4x squared. Now, I think 4 will divide into all of that stuff. I'm hoping it does. Let's just divide everything by 4, just to make it a little bit easier on the factoring game. So 0 is equal to x squared. 4 into 180 goes 45 times. Plus 4 into that goes twice. 3, that'd be 9, 2, 6, I believe. 2, 9 times 4 is 36, yeah, and 2, 424 is 6, yeah. Okay, so now I need to factor this. Things that multiply to 296 add up to 45. I'm in trouble. Let's pull out decimals. Okay, decimals. Here we are. So what I'm going to do is I'm just going to type that out. So y equals, it's very small, x squared minus 45x plus 296 Whoops, that's a times. Plus 296. There we go. Okay. So, if I move that over a little bit, it looks like it's going right through there, doesn't it? At 8, is that 8? Yeah, 80. What's the other number? Come on. 8 times 37? Yeah, 8 and 37. Okay. So, I'm picking 8 and 37. 8, 37. So x minus 8, x minus 37. I could FOIL that together, but I think you'll see that it comes out. So, using the 0 property, either x minus 8 is 0, or x minus 37 is 0. So x is 8, or x is 37. Now, it can't be 37, because if you take a look, x is 37. If I put 37 in there and 37 in there, there's no way it could be 40 centimeters. So I'm getting rid of the 37. So 8 is the length of that x. So if I draw my box again, so this side was 40, but when I cut that corner out, if this distance is 8 and this distance is 8, that's 16 off of the 40. So this total distance here would be 24. So they say the length of the sides of the squares. Oh, they just want to know what the sides of those squares are. Oh, well, we figured that out already. It's 8. But if I wanted to know the length of the box there, this side would be 24. Then this whole side here is 50, but I have to subtract those two 8s, so I have to subtract 16. So that distance there would be 34. And just test that to see if that works. Multiply 34 by 24, and hopefully when you do, you get 216. All right, there's some homework help for you for the quadratic equation section.